Yeah, what we just saw was more than 100 years of car manufacturing at Mercedes-Benz. But don't worry, we won't bore you with car manufacturing today here. We're here for Kubernetes, and these 7 years of running Kubernetes clusters for Mercedes-Benz had a similar transformational effect on the software development at our company. Hello, everyone. My name is Philipp. I'm a cloud architect at Mercedes-Benz, and I'm here with Jens.
Hi, I'm Jens. I'm a DevOps engineer and was one of the first engineers with the project.
So today, Mercedes-Benz is the most valuable luxury car manufacturer in the world. But for us as an IT department in Mercedes-Benz, our mission is not only to build the best luxury cars in the world, we also want to be leading in building software for our cars. And of course, as you know, the best software needs the best platforms to run on. And this is why the Kubernetes platform that we build is our contribution to our company's transformation into a 100% digital car manufacturer.
At Mercedes-Benz Tech Innovation, we are professional software engineers, strategic partners, and creative visionaries. We are proud part of the Mercedes-Benz family and supporting pillar within IT. As a wholly owned subsidiary, we develop technology innovations exclusively for Mercedes-Benz, driving the transformation to 100% digital. We set the standards in the context of car connectivity and the digitalization of vehicles and sales. Oh, and I almost forgot, we operate like 1,000 Kubernetes clusters.
So 7 years ago, at Mercedes-Benz IT, there was only classic enterprise IT, as you all probably know it. It was a totally different mindset from what we have today, because enterprise IT is optimized for cost and for governance. It's not optimized, and it was not optimized for speed and for developers' experience. To give you a few examples, to get a virtual machine could take weeks. And then, of course, you have to set it up, install your application, and all that stuff. And also, developers and operators were separated. There was no DevOps. So the developers were already very agile, but they failed to deliver in the same speed because the infrastructure was not. So in 2015, a team of software developers set out to change that. So Jens, what did we do?
I was part of this team of developers, mostly young developers, that wanted to modernize the world of IT operations in our company. We wanted to restart with a greenfield approach. Most of us were coming from agile developer teams. And we needed to change how we host, because we were developing in an agile mode. We were having fast deployment, but failed at delivery. We did not care about the classic enterprise way of running IT. The public cloud was not really an option, because in our company we had lots of governance and a week-long expensive process on getting to the public cloud. So in 2015, we compared the options for modern orchestration of microservices. And we chose a new cool kid on the block, Kubernetes, starting with a productive Kubernetes 0.9 cluster. The deployment velocity was suddenly unheard of in the company. If you visited the Mercedes-Benz car configurator like 5 or 6 years ago, parts of it have already been hosted on Kubernetes and deployed with a CI/CD pipeline. In the beginning, we had 2 Kubernetes clusters, one for production, one for staging. Those have been deployed on managed virtual machines from the data center. We had to order them using classic tickets and Excel sheets. Kubernetes was already installed using configuration management, so kind of DevOps style. The clusters had namespace sharing. Each project had their own namespace with all the issues attached, limited permissions. And if a customer wanted to get on board, they actually still sent us an email. In 2016, I assume we were running the world's largest Kubernetes cluster, if you consider routable IP addresses, not the nodes below. We were hosting these Kubernetes clusters in a classic 3-tier architecture: web, app, databases. And each of those pods running in there needed a public IP address, so it could be governed using the classic data center firewall processes. This was in times when traditional data center hosting was planned like months ahead. We onboarded our customers, our application projects, within like 1 week. Anyway, we already managed self-service access for developers. In the first days, a customer asked me, well, the application development is done. Who will I send this Docker image to so you can run it? And he was kind of puzzled when I replied back, well, there's an API for that. You can and you will have to do this on your own. We soon realized this large shared cluster will not really fit our needs. We had to coordinate upgrades with those different app teams and their go-live dates and everything. The customers had restricted permissions, could not do whatever they needed to do with ingress controllers, stuff like this. And in the end, all of those customers had kind of diverging requirements. We compared the alternatives for Kubernetes fleet management to host more than one cluster. But back then, there just was no vendor distribution around for Kubernetes fleet management matching our requirements. On the other hand, we had engineers with in-depth understanding of the technology used and finally decided to create our own solution. Back to the requirements. Philipp, how did we scale out?
So in 2017, we relaunched our Kubernetes platform for better scalability and for an even better fit for the requirements of our application teams. So the first thing we changed from managed virtual machines to infrastructure as a service. And OpenStack was the only way for that. So we replaced the virtual machines that we got from the data center team, where we had no control, and deployed our own OpenStack, where we had full control over it. And also, this infrastructure as a service can directly be consumed by Kubernetes via its APIs. So it's automated in that part. The second thing that we did back then, we learned from the first platform that the shared cluster was not ideal. So we moved to dedicated clusters. Each application team could get their dedicated Kubernetes cluster. This suits the requirements of our application teams much better because they have a better separation between applications and they have more control over their environment. It also had a huge advantage when it comes to Kubernetes upgrades because we were able to upgrade each and every cluster individually and don't have to upgrade one shared cluster for all the applications. However, there were and there are still no strict rules that you have to deploy your application to a dedicated cluster. You can still share your cluster if you feel like it. So there are still app teams within Mercedes-Benz that share a single cluster because they are close by from an organizational point of view. So in this first iteration, the platform team still had to trigger the deployment of a new Kubernetes cluster. So there was no automation for the developer for the deployment of the cluster. And besides SaltStack, Terraform was introduced here to deploy the resources in OpenStack. So we also adjusted the tooling. And then a few months later in this year, SaltStack was also removed. This was one of the tools from the first generation platform. And we introduced Ansible for the automated deployment of Kubernetes resources. And we added Consul and Vault to store our configuration data. But the most important part at this time was that we developed a provisioning API that automates the cluster deployment and the lifecycle management. So this provisioning API was really a very important step towards true self-service from a developer perspective. So now the API is doing all the things, but still at this stage, the API was still triggered by the platform team. So 2018. And finally, we got what everyone asked for in our developer community, a self-service portal for the Kubernetes clusters. At this time, the company also adopted ServiceNow, and we decided to use just that to build our portal for self-service. So the self-service portal then triggered the provisioning API, and the cluster provisioning was fully automated from a developer perspective. And clusters were ready to use just after 15 minutes for them. The team was really excited about this achievement because this was completely uncommon in enterprise IT in Mercedes-Benz, because everyone was used to send a ticket to get something, and here you could do all the stuff on your own. And this was really a confirmation for us as a team that we not just have to do automation first, we have to do automation only to achieve this. And here's another example for automation and self-service, the evolution of our networking and load balancing for the Kubernetes platform. So when we started with the platform, we also started with the classic and traditional way of network load balancing from the data center. So there was a hardware load balancer in front of the platform. The data center team configures this load balancer, and then it forwards to the application that runs on the Kubernetes cluster. With the introduction of the self-service portal with ServiceNow, we also made our provisioning API to deploy load balancer as a service on OpenStack. So this was the first step to free ourselves from the data center hardware load balancer processes and enable developers to manage their load balancing on their own. And then in the final iteration, and this is still the state that we have today, now the developer can create a Kubernetes service directly in kubectl, and the OpenStack Cloud Controller Manager will manage the load balancer as a service and the floating IP directly in OpenStack and links it back to the Kubernetes service. So now we can even get rid of the self-service portal, and the developer can do everything on the command line. What we also did in the networking area is we eliminated the most hated IT process in the whole company, firewalling. We removed all the physical firewalls in front of the platform and moved the responsibility for filtering traffic and establishing rules also to the developer. So today, a developer can configure firewall rules inside their Kubernetes cluster just for his cluster and for his application. So that's it. We did it all. We automated all the things. We had a scalable platform. Was there anything else left to do?
Hi, we are Eficode, and we organize the DevOps conference. What developers really want is to see their software live. Minimizing the time from idea to software delivery really makes sense, whether you invest in CI/CD, cloud-native development, or continuous experimentation and learning. We would love to speak to you about how to remove the pain and uncertainty from your software development lifecycle. You can find us at eficode.com. The links are in the description. Have a great time with the DevOps conference talks.
2 or 3 years ago, we've been running more than 100 Kubernetes clusters. The customers are running in production. So, seems we are done. Of course not. A large-scale cloud platform can never be finished. The company changes. The ecosystem changes. Kubernetes changes, and of course, the customer requirements change all the time, too. Mercedes-Benz, as Philipp already introduced, has a central IT service management platform, ServiceNow, which is used with lots of functions. It's a configuration management database. It handles changes, tickets, whatever. Cost management is of course very important. And finally, it offers a company-wide view on all the IT assets. On the other hand, it has a rather slow change process. So this was a pain point. This did not feel like DevOps. Remember where we started this entire project? The app teams had their features delayed, could not deploy on their own, failed to deliver their product increments. Now we felt the same way. We soon realized, well, the IT service management platform is not required for the day-to-day changes, as long as the information in the system is up to date. So we split apart those governance requirements from our self-service systems. And soon we've been able to add more advanced and interactive features to our customers. Features like direct access to the clusters, not only through kube control if you've got the network reachability, but also you could now use the web terminal, which was actually quite important because lots of those classic, more like product owners and so on, they are getting more technical. They wanted to access the clusters, but they've not been able to because they cannot install any software to their machines. The Kubernetes dashboard is the same category. We added some automated best practice analysis for the applications deployed by the app teams, which is really interesting because it both helps the app teams to provide a better and more stable software, and at the same time reduces support effort on our side. The system has a rather flexible permission management, and it also allows all these external developers not being part of the core company to access those clusters, which would never be able to get access to ServiceNow. And finally, we integrated all this with a well-defined API. So other projects could actually automate the cluster management on our side. All this would be pretty complicated if we'd have to adjust to the very generic IT service management data model. This cloud management platform is shared with some other projects around us. Projects it's not only us hosting Kubernetes, we've also got projects running databases, observability systems. All this is a shared cloud management system offering great integration and easy to use. And now we are able to deploy to production as we need. We are delivering customer-facing features in the same speed the application projects are used to. On the other hand, we changed our cluster provisioning to a more cloud-native approach. So we were replacing those rather traditional deployment models. Salts like, or later Ansible, we had Terraform, with the new community-driven operator-based architecture around Kubernetes Cluster API. For example, when we used Ansible for deploying those additional Kubernetes resources like monitoring agents, we were stuck with a rather slow deployment process. We were like upgrading those components 2 or 3 times a year, and rather a big bang deployment. Now we're using FluxCD, which allows us much more frequent and small upgrades all the time. We had, in the early days or in the later days, single-shot Terraform scripts. Single-shot, why could we do this called single-shot? The customer orders a change, our automation runs, executes those Terraform scripts, and if it fails, it fails. Terraform stops. We have to fix it. Cluster API is running an operator kind approach. So it's constantly observing the real state and the desired state, and it's reconciling. If something's broken, it's just fixing this by recreating. And end up, we just recreate a virtual machine and discard the old one. Don't care about it. Even better, because we now align with lots of community projects around us. We are not the only ones running internal code. We are able to bring our solution to the public cloud by simply replacing the cloud provider in the backend. So we can concentrate on our core task. We are there to provide our application teams with the best possible integration to the company, like networking, and still are able to provide a seamless multi-cloud environment. We created the system based on 100% free and open source software, both built and operated by the same DevOps team. We soon realized the benefits. Something's broken. We don't worry about licensing issues and sending in support tickets. Instead, we enjoy the four freedoms of open source. Not only are we able to run the code, we are able to read it if we need it. We are able to modify it and fix the issues or extend the code as we need. And finally, of course, we share back our improvements. This was not always easy. In the beginning, we lacked a formal contribution process. We actually submitted patches in our spare time with private mail addresses because we haven't been allowed to otherwise. But this was resolved. By 2021, Mercedes-Benz ranked under the top 20 companies contributing to Kubernetes worldwide. Remember, we are a car manufacturer. If you want to look up, we've still been called Daimler TSS last year, so don't wonder if you don't find Mercedes-Benz in the tables. Today, we are part of the Cluster API Provider OpenStack maintainer team. And we had impact beyond the project. Together with other pioneers in the company, we lobbied for change. And Mercedes-Benz released its open source manifesto. Not only do we commit to participate in active role, we prefer open source software. If you're interested, take a look at it. And of course, it's open source, so if you have desire, reuse it, change it. So, Philipp, where are we now?
Yeah, today, as the title of this talk already states, we are running more than 1,000 Kubernetes clusters on-prem in our data centers across 3 regions. So in Europe, of course, since we are European, a German company, there's the main workload. In the US and in China. We are operating these clusters 24/7 out of Germany. We are performing rolling Kubernetes upgrades on all these clusters. And we are hosting, of course, hundreds of apps on this platform. And on this journey with this platform in the last years, we created also one mindset that spread among our developers. And this also enabled us to get more people in the platform teams and to establish new teams that did more things for our developers. Today, there's a whole ecosystem beyond the pure Kubernetes clusters. There's a team that provides add-on services that are integrated into the clusters, services like logging, monitoring, hosted databases, and container security tools. There's also a team that provides pre-configured and maintained Helm charts and container images that solve common developer challenges within the Mercedes-Benz context. And as Jens already said, now we are going into the public cloud. We are starting with AWS, we will add Azure soon, and we can just put our platform on this public cloud thanks to Cluster API. And all these platforms are also supported by our developer community, which is very important for us. So the central hub for our developer community is Mattermost and GitHub. So again, the idea stays the same. So we want to save our developers from ticket systems. We don't want them to issue tickets if they don't have to. So the developers can reach our platform team directly in Mattermost and chat with them. So the same team that develops and operates the platform also answers questions from developers. And this, again, only works because we have this high level of automation that does all the standard things, and we have time to engage with the community. Another thing that we wanted to achieve and that already has a great success is that developers help each other. So this large Mattermost channel where thousands of people are in, if there's a question from one developer, it often happens that another developer answers this question. The same for GitHub. So developers also open pull requests to create or update documentation. And of course, we want to get feedback from our community. So we are also doing meetups with our developers to incorporate their feedback into the next steps of the platform. So what did we learn in these years with our Kubernetes platform? 25 years ago, Mercedes-Benz learned something about how proper testing of cars is done in Sweden. Maybe some of you guys remember this picture. And of course, we also learned something in the last 7 years with our platform. One of the main and most important things, of course, as I already said, is automation. Automation first, automation only, because only if you automate all the things, you have time for the more important stuff. to engage with your community, to build new features, to work on the important stuff, not on the daily stuff. The other thing that we learned is that scaling an on-premises cloud is really, really hard. So I learned this personally because together with a colleague, I was responsible to scale this cloud. We had to bring in new servers into the data center, and it took us a while until we got them operational inside the platform. And at the same time, developers were waiting for their Kubernetes clusters. So this was really hard.
Consider the developer benefits. So I can't really quote any of the talks in here because the entire conference seems about platforms and a developer community. Think about data and center integration. It's not about Kubernetes. Kubernetes is hard too, but your company is even more complicated. And architect for change. This project is now running for like 7 years. Consider your infrastructure like microservices. Be able to change single parts, upgrade them, and still keep the entire system put together. Don't do a hard upgrade or something like this.
And of course, as I already said, one of the biggest learning is that our community-driven approach to operate this platform was really one of the major success reasons for this platform with our developers. So the conclusion for us after all these years is really that the mindset and the culture, of course, that we developed with this platform, while operating this platform for all these years, this is what really makes this valuable for our developers, and also what makes Mercedes-Benz software even better. Thank you very much.